is a very powerful tool that's used in a lot of systems dynamics. I show a few, and I'm not advocating a certain tool here, but I just want to give a few examples here. One is called SARL. It sort of looks like this. You define the agents, what they're, now the reason why you can get very dynamic and I should say representative effects where the agents are giving sort of true human-like effects or very realistic effects is that you encode that each of these agents have their own incentives and they take actions based on how they're incentivized. Well, in a code like SARL, you can write the code in these sort of block diagram forms that specify all the agent incentives and how they act. Net logo is a popular that's been used in the past. Now this is a net logo screenshot that I think this is showing like bacterial growth, but there are also other, this is also called the game of life, which is something that's often talked about, cellular automata and things like that. You can also use, you can put together agent-based models to, I talked about, if you were trying to look at what would be the impact of shutting down trains on disease spread, you can model a whole population using agents and then tie that to a GIS model and transportation model like this and look at the impacts over an entire city. So anyway, now you can imagine if like I said, if I wanted to model, go beyond a simple math model like this, and I'm a policymaker in a couple aspects. A policymaker in the sense of I want to design, that there are degree programs now on urban planning where they say, and imagine this is, we're not talking about COVID-19, we're talking about heart attack risk. And we say, okay, I want to design a city, it's transportation, or I want to design housing, and I want to find out what should the transportation network be. Well, think about it. What is the long-term impact? It's not just physical health, it's psychological health and all these other factors. Well, imagine that I have all those factors and it's a high-level system design. I'm an urban planner and I model agents, and then I put in some type of disease risk model where I say, okay, if I tweak this transportation network so that all the new housing is going to be within, say, a half a mile of public transportation, and it's also going to be built so that it's within half a mile of a local farmer's market or whatever it is where people are getting fresh fruit and vegetables, et cetera, et cetera. And I'm going to design this, I'm going to put green roofs on the top of these buildings, and you can think of many different things where you can think about even community design in terms of overall design of health or optimizing the entire system in terms of health, safety, well-being. I think these are really interesting tools that can be applied in a lot of different areas. Now, what is emergence? This may be something heard of before. As the name implies, emergence is something that's sort of spontaneously arising, and it arises in complex systems. And this is a very beautiful drawing, I think. Maybe you've seen this before. I used to see these in fields that were by my house. Birds would come in and make these extremely beautiful patterns. What emergence is that we talked about the three types of order. What emergence is, it's a higher level synergistic order from the bottom up, meaning that it's different than top down or a command and control type of structure where I'm telling all the individual, like imagine a military that's top down and command and control. I'm telling all the way down, I'm training people and all the way down to the individual, soldier level, here's how you act. This is the exact opposite. This is basically saying, giving each of the individual agents, or each of the individual agents have their own behavior based on their own incentives, and a very small number of instructions. The same thing happens with bees. You can imagine that or ants for that matter, they don't have a lot of bits that characterize their neural circuitry, but nonetheless they can form very complex behaviors. And the key attribute here is that based on those very simple that very simple logic and behaviors at the individual component level, there's order that arises spontaneously so that this group of birds is acting like its own structure. It's almost like it has its own being. has its own ontology, so to speak. So and this gets a little bit more metaphysical, but it turns out that there's a lot of debate about what consciousness is. Is it possible to simulate consciousness? Well, consciousness is something that is an emergent property that emerges outside from neural circuitry. We don't actually even understand how it happens.